Hey, today we are doing lesson 15. We're looking at some more inequalities, and we're going to be working to solve and write inequalities and also do some graphing today. So for the first activity, it says select all the values that are solutions to negative x is greater than or equal to negative 4. All right, we have 6 different solutions here listed, and what we need to do is we need to take each of them, pretending that it's an x value, put it into the inequality here. And remember, because of this negative sign out here, we're going to be making everything that's an x value its opposite. Okay, so if we put in 3, now it becomes negative 3. If we put in negative 3, the opposite of negative 3 is positive 3. So just as a reminder, this is really going to be negative 3 when it's put into the inequality. So you're thinking, is negative 3 greater than or equal to negative 4? And then for the next, this is actually the opposite of negative 3, or 3 is 3 greater than or equal to negative 4. So that gets the first two started for you. Decide if these are true solutions for x, both of these here, and then do the other 4, please. Okay, hopefully what you found is that A, B, C, D, and F are all values that can be solutions in the inequality here. They can all be values of x. Okay, let's go on to the next part. And for the next activity, this is, we're going to do this several times to practice this skill. It says, let's investigate the inequality x minus 3 is greater than negative 2. We're going to complete the table. Now, unfortunately, this copied very terribly, but what we have here in the top, oops, in the top here, that's our x value. And then in the bottom part of the table, it's our x minus 3 part. So what we're doing here is, and for all 3 of these examples, we're using the same values for x. These are just hypothetical values. We're saying, okay, well, if x was negative 4, what would it be in the inequality? Because we're taking 3 away from x. That's what this value is going to be here. So we're saying if x was negative 4, let's take 3 away from it to see what we would get. 3, subtracting 3 from negative 4 is negative 7. Okay, and then that's all we're going to do at first here when we complete the table. So for the next one, if our x value was negative 3 and we took 3 more away, then we would be at negative 6. Okay, a couple of these are done for us. If we're at negative 1, then our x value would be negative 4. And you can follow a pattern here. You can see that as we're getting 1 closer to 0, so is our x minus 3 value. So we could probably continue that. We want to try that with a couple of these to make sure it doesn't change. But 0 minus 3 is negative 3. 1 is going to be negative 2, and we are continuing that pattern. So 3 minus 3 here is 0. All right, and now that we've completed the table, that we know what each of these x values do in the inequality here when we take 3 away from it, what we need to determine now is graphing the solution to this inequality here on the number line. Okay, now traditionally we would put 0 here in the middle, and then we're going to take a look here at this. Now, for the inequality to be true, let me write this out here, the left side of the inequality must be greater than negative 2. Now remember, the x side of the inequality is x minus 3. So we're looking here at this calculation that we did in our table to find all the values of x minus 3 that are greater than negative 2. Well, negative 7 isn't greater than negative 2, neither is negative 5. Negative 2 we need to be careful because if this was equal to, greater than, or equal to, this would be true, this would be correct. So this is kind of a turning point here in our table here. Okay, in this case, it's not a solution, it's not correct. So all of these previous are not correct values for x. They don't work in this inequality. But as we go forward, -1 is greater than -2, so is 0, and so is 1. All of these are solutions. That means that all of these values for x work. They're, they make that inequality true. So now if we're graphing our solutions, this is a graph of x values. So just keep that in mind. So now we used the bottom part of the table to figure out which values work. Now we're going to look at the values for x, and 2, 3, and 4 work. So that's what we need to show on our graph. But we're going to start actually right here. So when x was equal to 1, it made the same value on each side of the inequality. And we said that's not a solution because we don't have a greater than or equal to sign here. But this is still where we're going to start on the number line. We're going to start at 1. So 1 is right here. This is where we're starting, and this is where we need to decide, should we use an open circle or a closed circle? Okay, open, closed. Now, we've already talked about this, and hopefully you remember, open circle does not include the number that the open circle is on, and a closed circle does include it. Okay, the way I remember that is I think of an open circle like building a fence around that number. It's a silly way to remember it, but I'm building a fence around this number and I can't get to it. So an open circle doesn't include the number that it's at, but only anything outside of the fence, whether to the right or the left, whichever way our arrow's going. So since we said 1 is not a solution here for x because it gave us the same value and we needed to be greater than that, this is not a solution, so we don't want to include it. We're going to use an open circle. So at 1, and we could do this above the graph just so it doesn't get confusing, we'd put an open circle, and now we need to include the other values that work for x, 2, 3, and 4. So we're going to move our arrow to the right. Now, just a really quick side note, the reason that we don't start at 2 here on the number line is because anything greater than 1 will work as an answer to this. That means answers like 1.1, 1.2, 1.3, all these little tiny spaces between the whole numbers are solutions for this. So we need to start at the point where it's not a correct answer and move from there to include everything in here that we would have missed if we just started here at 2. All right, I hope that makes sense. Let's do a couple more, and I think if you have any questions, hopefully we can get those answered. So we have a new inequality, 2x is less than 6, and we're going to complete the table for all these x values. Again, this top column, or this top row, excuse me, is the x value. The bottom row is the part of the inequality here, which is 2x. So all we need to do is take these hypothetical x values and double them to fill in the table. So we're doing multiplication here with integers. Remember, when we multiply a negative times a positive, we get a negative answer. So that's -8, -6, -4, -2. Now anything multiplied by 0 is 0. And now we're switching to positives. 1 times 2 is 2, and 4, and 6, and 8. And you can see that pattern, hopefully, as we complete it, as we fill it in. So we need to determine the correct answer choices. So we look at our original inequality, which was 2x is less than 6. So that means that our 2x calculation, our bottom row here, has to be a value less than 6. Okay, -8 is less than 6, so that one works. -6, all the negatives are going to be less than 6. 0 is less than 6. 2 is less than 6. 4 is less than 6. 6 becomes the point where now it's no longer a correct solution to the inequality. And this is going to be that marking that we make on the number line. Okay, and clearly we're going to go less than it for all of these values because 8 is not less than 6. This is not a solution to it. And neither is 3 technically because we don't have that less than or equal to sign here. So this does mark, however, where we're going to start on our number line. If 0 is here in the middle, we would go to, now remember, we're graphing the solutions for x here. Our x values are the top row of the graph, of the table, and we're starting at 3. So 1, 2, 3 here. Now we just decide, do we need an open circle or a closed circle? Do we want to include this in our answers or do we want to exclude it? And we want to exclude it. So we're going to use an open circle at 3, and then we want to show all values less than that. Okay, let's go on. If we look at the third example here, we have a slightly different inequality. Our inequality this time is -2x is less than 6. So we have our hypothetical x values again, and now -2x for the bottom row. And why don't you go ahead and fill in the bottom row of this table, and then we'll compare answers. All right, remembering our rules for multiplying integers, 2 negatives being multiplied becomes a positive value. So -2 times -4 is +8, +6, 4, 2, still 0. And now we're multiplying a +1 times a -2, and we're going to go to the negative now. Okay. These calculations need to be, because of our inequality, less than 6. So we're looking here for our values that are less than 6. Well, 8 is not less than 6, so that one wouldn't work. 6 is not less than 6, so this is going to be our changing point here. But all the values after that, 4 is less than 6, 2 is less than 6, and all these negative quantities. So those would all check out. Here would be all our values for x. Here would be our marking point on the graph, and this would represent values that do not work, that are not true. Also, notice how they picked when they're checking this, they're picking an equal number of negative and positive numbers, and that's really helping us see which direction we should be going on this graph. So we're going to start here with our x value of -3. Now, because it's not equal, less than or equal to, we can't have this as an answer. So we're going to use an open circle again. If we have 0 here, we're going to go to -3. And we're going to make our open circle because -3 is not a solution, but anything greater than that, including some of those negatives and all the positive numbers, is a solution. So we're going to go to the right to include those answer choices. All right. The last question asks, how are the solutions to our first inequality, 2x is less than 6, how are those different from the solutions to -2x is less than 6? The only difference here in our expression, in our inequality, is that we're multiplying by a negative coefficient and a positive coefficient. So let's look. We had everything going from 3 into the negative for our solution. So anything less than 3 was our solution here. This was anything greater than negative 3. So it changed our solution from what was previously positive 3 to negative 3, and it changed the direction that our answers traveled in. And that ties into what we've talked about previously, where this inequality symbol changes at certain times when we're solving these inequalities. And that's what we're going to be looking at here shortly. Okay, so onto the back of your sheet, we have a little more investigating to do. We've got an inequality. This is a two-step inequality because we have two terms here. And it's asking us, is this inequality true when x is equal to 0? What that wants us to do is more or less rewrite the inequality, putting in 0 for x. So I'm going to take negative 4 times 0. So I'm going to write that 0 in parentheses there to show they're being multiplied. Plus 5 is greater than or equal to 25. So there's my inequality. Now I just need to check and see if it's true. If I calculate out this side, it's going to have to be greater than or equal to 25. So negative 4 times 0 is 0, and 0 plus 5 is 5. 5 is not greater than 25. So to answer this question, no, it is not true. But then it wants us to try for x is 7. Rewrite it. Negative 4 times 7 plus 5 is greater than or equal to 25. Let's calculate. Negative 4 times 7 is negative 28. Negative 28 plus 5 is still going to be negative, so there's no way that's going to be greater than 25. And again, no, that's not a solution. Finally, we're going to check with negative 7. So negative 4 times negative 7 plus 5 is greater than or equal to 25. Multiplying two negatives becomes positive, so that's positive 28 plus 5 more. That's going to be greater than 25. So here we have a solution. Yes, that is a solution. Now we're asked to graph. So part of today's lesson is getting efficient with this. The previous part here where we looked through the tables, making a table is not always the most efficient way to do something. It's a good way to understand what we're talking about. Now we're going to go to the more efficient way, and that is to solve these inequalities like an equation. So I'm going to rewrite negative 4x plus 5 greater than or equal to 25. I'm going to think of this as an equation the whole time until I get to the very end. So I'm solving this equation. It's a two-step equation with these two terms. I need to get rid of this plus 5, and I need to get rid of this times negative 4 so that I can isolate my variable, isolate x. Let's do that. We'll take away 5 from each side and rewrite what's left. Since this has canceled each other out, negative 4x, and 25 minus 5 is 20. So I've got my two sides of my inequality here. Now, I don't want to be multiplying by negative 4 times x, so I'm going to inverse divide by 4, and then do the balance on this side. Since negative 4 divided by negative 4 is 1, we have 1x left over, and 20 divided by negative 4 is negative 5. Now, here's the important part. I need to decide, should my inequality symbol stay the same or should it reverse direction? There's two ways to determine this. Okay, one, we have a rule, and we talked about that rule yesterday. Okay, if you forget the rule, you can always try a term in your inequality. You can try a value for x and see if it's true. So I would always, because an easy one to work with would be a number like um, 0 or 1. Those are just easy numbers to calculate in your head. So let's say, we already did this, but let's say x equals 0. If I put a 0 in here and solve this inequality, -4 times 0 is 0, plus 5 is 5, and 5 is not greater than 25. So 0 is not a value of x. We said that right up here, when x equals 0, no, that's not a solution. So let's look here. If we're saying 0 cannot be a solution for x, and we need to include all the values of x, well, we don't want to include 0. So if I were to put the original symbol, which was greater than or equal to, 0 is greater than or equal to -5. And we just said 0 doesn't work. So we have to reverse this symbol. We have to show that the x values must be less than -5 to be an answer. And 0 is not less than -5. That's how we can show that this symbol needed to be reversed to include all the values for x. The other way to think of it is anytime, remember the rule is anytime we multiply or divide by a negative number when we're solving our inequality. Here we divided by a negative number, that reversed our inequality symbol from what it originally was. So here on the graph, when we graph our solutions, if 0 is here in the middle, we go to 1, let's see, I might move 0 up a little bit just to have a little more room to work. We're going to go to -5, 1, 2, 3, 4, 5. Now we have a less than or equal to sign. So I can include -5 here in my answers. I'm going to use a closed circle to include -5 and any values less than that. That would be how to graph the solutions to this inequality. Now, it is your turn. So take a look at 2, and you're going to be working with fractions. Don't freak out. You can do this, but answer the questions so we can decide, should this less than symbol remain when we write our answer, when we write our solution for x, or should it reverse and become greater than? Okay, for 2, I hope you would have said that yes, 0 does work as a solution here. And when we graph it, we need to um, start, let's see. So in this case, the inequality symbol doesn't change directions because we didn't multiply or divide by a negative number when you solved it. So our starting point is going to be at 3.5. So I'm going to put 0 here. 1, 2, 3.5 would be about here. And we don't want to include it because we're not dealing with an less than or equal to sign. So we're going to put an open circle at 3.5 and keeping our symbol as less than, show an arrow pointing to the left. Let's take a look at the next one. Okay, again, solve this for x. Decide if we should reverse this greater than symbol to be a less than symbol, and then put it here, put your results here on the number line. All right, what you hopefully came up with is that you would not reverse the greater than symbol, and x is greater than 1.8. So we're going to graph that. When we get something specific like that, I might just stick one of these tick marks on the number line and call it 1.8. I know because it is greater than and not greater than or equal to, I'm going to use an open circle. I don't want to include this as my answer. So an open circle, and all of my x values have to be greater than 1.8. So I'm going to go to the right. Think of on your number lines, these are the greater, these are the less than. So wherever you put your number, go to the right to be greater than it, go to the left to be less than it. Okay, on the last one, again, go ahead and solve it. What I hope you found is that x is greater than or equal to negative 2/3. We don't want to do a repeating decimal here. That'd be negative 0.6 repeating. That's just hard to put on anything. Always try to go to a fraction. It's just cleaner. But you solved that. Hopefully you found, because you had to divide by a negative number to solve it, that this less than or equals to sign switches direction, becomes greater than or equal to, and when we graph it, we put negative 2/3 on our graph. Remember, greater than, less than. So our x values are greater than or equal to negative 2/3. We're going to go to the right here on our number line. Because it's equal, we want to include this in our answers. So we're going to put a closed circle and send it to the right for all the other values. I hope this is becoming really easy for you to do, kind of second nature. Would you please look at the last couple of questions there and fill those in, check your answers at the end in the notes to see that you solved them correctly. This one actually doesn't have you solving the inequality, just determining, sorry, this one here, just determining if x is less than 2.5 or x is greater than 2.5 and decide which this would apply to. Try to do that without actually solving each of these inequalities. And what I mean by that is think of a number that's less than 2.5 that we could try in both of these inequalities to see which one it works in. Think easy numbers. Think of an x value less than 2.5. Maybe think of x is equal to 0 or x is equal to 1. Both of those are less than 2.5. And if they work in one of these inequalities, then this would be a value for, this would be a way to represent the answers, the values for it. So try an easy number in these two inequalities, then determine which one has x is less than 2.5 as a solution. Okay, everybody have a great day.